In lesson 1.3, we're going to be talking about angles. And from your previous geometry units, maybe in middle school, you should know that your angle is formed by two rays that share a common endpoint, provided that the two rays are non-collinear. And that common endpoint is called the vertex. The sides are the two rays that make up the angle. Now, one thing you're going to want to make sure that you know is you're going to want to make sure that you know how to properly name an angle. Sometimes your angles are numbered, and you can see here this has the number 1. We would use the angle symbol. I could just call this angle 1. I could also name it according to the vertex, and so I could also call it angle R. Lastly, I could use the sides or the rays of the angle, the 3 points. I could call it SRT, angle SRT, but I just have to make sure that that middle letter is always the vertex. I could also call it angle TRS, but again, R is the middle. Now, when you look at diagram 2, you'll notice that with diagram 2, I couldn't just name this as angle A because there's more than one angle possible. So I'm not sure which angle would we be talking about, the small one, or the large one. You have to be more specific in a case like this. In other words, if I wanted to name and I was referring to that angle right there in the red, I would have to use 3 letters and I would have to say angle CAD or angle DAC, with the vertex point being the middle letter. Now, when you measure an angle, the measure of an angle is given in degrees. We know that in a full circle there are 360 degrees. However, when we're given the measure of an angle, because we use the smallest amount of rotation about the vertex, our measure should always be between 0 and 180 degrees. I can see over here with angle GPS, there are 2 different measures, but again, using the smallest amount of rotation, we would have a measure of 136, always falling between 0 and 180, or equal to. I'm hoping that you've used a protractor before. That is what we're going to use to be measuring our angles. And of course, as review from before, we have different types of angles. We have the acute angle, which would be less than 90 degrees. The right angle, which is exactly 90. Obtuse, which is greater than 90 but less than 180. And of course, the straight angle or the straight line, which is equal to 180 degrees. If you were to use your protractor to measure the angles, I will remind you of a couple things. That you want to make sure that your vertex point is in the center hole or the crosshairs of your protractor, and one of your rays must line up with 0. Now, in this case, when I measure my angle, I can see that it goes through right here. There's 2 different numbers. Right here, it is showing me a measure of 60 or 120. How do we know which one to pick? Well, because we know that angle 1 is acute, we know that we would pick the smaller number. And we're going to say it's about 60 degrees. And this little squiggle here, squiggly equal sign, that means approximately. Likewise, if I measure angle 2, I'm going to line up my vertex point. I'm going to line up one side with 0, and I know it's acute, so I know I'm going to use the smaller measure. Opening here, this looks to be about 39 degrees. And finally, I can see angle 3. Angle 3 is going to be obtuse. It's larger than 90 degrees. And opening up here, it appears to be just below 140 degrees. I think it comes out as approximately 138. And if you're a degree or 2 off, that is just fine. Looking at example B, this is something that you might see in your textbook, and I'll tell you sometimes they give you the protractor. That means you don't want to take another one and try and set it on there and measure, because sometimes they're not drawn to scale. We simply want to use the one that is given to us. In number 1, they're asking me to find the measure of BOA, angle BOA. If I come over here and find angle BOA, I can see I'm wanting to know the measure here. It's acute, so I'm going to use the smaller number, and I find that it goes through the 40 degrees. Angle DOB. When I find that angle, DOB, I can see, well, this ray goes through the 40, 140 mark. I think I would use the bigger number because it's obtuse, but they did not start at 0. So I actually need to think about subtracting that part off. It's not going to be 140 degrees, but it's going to be 140, and this little slice right here measures 15 degrees. So I'm going to need to subtract that off, and I find out that that measure comes out to 125. Finally, my measure of EOC. EOC. Well, EOC is going to, I'm opening it this way, and so I know it's more than 90. Sometimes kids are confused, is that 115? Well, no, we're opening up from left to right, so if this is 100, my EOC angle, that's actually going to be 105. Just like we had congruent segments, we can also have congruent angles. Congruent angles then are going to have the same measure. And if I showed you a little sketch of two angles that maybe look congruent, I'll tell you that in your textbooks they have to be marked. And the marking to show congruent angles would be a little arc. That shows me that those two angles are congruent. Now sometimes some textbooks or some worksheets will also put a tick mark in there, and that also means congruent. Just like we had segments that were bisected, we can also have angles that are bisected. So an angle bisector is a ray that contains the vertex of the angle and divides it into two congruent angles. So if I sketch my angle here, and I want to show an angle bisector, I know it's going to cut it into two congruent pieces or two congruent angles. Then in order to know that it is an angle bisector, it would have to be marked that these two are congruent. I would want to show the two arcs in there. And again, they may or may not put in those tick marks. Now, if we had a sketch like this, and let's just say our angle here was 40 degrees, we would know that this one was 40 degrees. And would you agree that if I were looking for the measure of the large angle, I could simply add 40 plus 40 to tell me that whole angle would be 80 degrees. That is what they call angle addition. And so for the angle addition postulate, they are going to say if S is in the interior of angle PQR, then we can take angle RQS plus angle SQP, and it should equal the whole angle of PQR, simply meaning we can add the two parts together to equal the whole. In example C, we're using our angle addition postulate. You'll notice they have a little m here. That means measure. The measure of angle XWZ is 121. The measure of angle XWY is 59. Can we find the measure of YWZ? We'll first start by labeling what we know. XWZ. If you go to find that angle in that order, XWZ, that's telling me that the whole angle has a measure of 121, or the larger one. The measure of angle XWY is 59. XWY, 59 degrees. Can we find YWZ? Sure. By angle addition, one part plus the other should equal the whole. Or we would know that, let's just take 121, subtract off that 59, and we would find that our angle would measure 62 degrees. Sometimes they don't give you the picture, and they're going to, I would suggest that you give me a little sketch. In question number 2, they say that KM bisects angle JKL. Let's just start with that. Let's just sketch an angle. JKL. K has to be the vertex, and it's being bisected by KM. Right down the middle. Now in the question they say that the measure of angle JKM is 4x plus 6. Let's go ahead and label that. 4x plus 6. The measure of angle MKL is 7x minus 12. Now by angle addition, I would add them together. It would equal the whole. But they're really asking me to find the measure of angle JKM. They're asking me what that angle equals. So I need to do a little bit of solving for x to figure that out. Now there's one key word in this example, and that key word would be bisects. We know that if it bisects, then my angles here should be equal. And that tells me the equation. 4x plus 6 should equal 7x minus 12. I go ahead and I solve for x just as before when we get our x's on one side and our numbers on the other. And we end up finding 18 equal to 3x, or 6 must be x. Now 6 is x, but again, we have to plug that in. If I take 4 times 6 plus 6, we find out angle JKM has a measure of 30 degrees. If you have questions on these examples, please come in and see me or send me a note. You can also check out the additional online examples from our textbook resources.